Hello, welcome back. I'm Dr. Ravindranath Rajotia, and I'm teaching you a course on circuits and systems. In the previous lecture, we took up an introduction to the Laplace transform and derived the equation of a Laplace transform. We said that given a signal xt, we can find out its Laplace, which is nothing but from minus infinity to plus infinity of the given signal xt e power of minus st dt. So what do you see here, that the limits are from minus infinity to plus infinity. We call such the transform as a bilateral transform, or it is a two-sided transform. Two-sided transform. I know that I can break this integral into two parts and write it as equal to minus infinity to some instance 0 minus of the given signal xt e power of minus st dt plus from integral limit of 0 plus to some infinity value of x of t e power of minus st and dt. So this is the right side part of it, and this is the left side. So xs is a combination of the right and the left sided. So this is known as a right sided transform, and this is known as a left sided transform. We also know that given a particular signal, let's say we are given a signal and the range of the signals falls in either the positive direction of the t or in the negative or in both the directions. So let's say if the given signal falls in this plane, then we call that system as a causal system. If the range it falls in this particular plane, then we call that system as a acausal or a non-causal system. So the positive side, it represents the past instances, and this side, it represents the future instances. So what is the response or the Laplace transform of the right-sided signal, which is a causal system? So in those cases, for a right-sided signal, its Laplace of x of t can be written as x of s, and this is nothing but from 0 to infinity of x of t e power of minus st into dt. Similarly, for the left-sided, the Laplace transform of given signal xt, which is left-sided, is nothing but x of s, and the limits are from 0 minus to minus infinity of a given signal xt e power of minus st into dt. So this is the causal system, and this is the non-causal system or a acausal system. Now, what we know that we are finding out the xs, which is nothing but the Laplace transform of the given signal x of t. So the transform xs and the xt, they form the transform pair. So xs and xt, this forms a transform pair. What does it mean? That from given xt, you can derive x of s, and from xs you can come back to x of t. So this this forms a transform pair. So also that means one, that if you're asked to find out the Laplace transform of a given signal, one, you need to find out the value of the x's. So there will be two parts. One is to find the x of s, and we also need to find the ROC. Only then the solution will be complete. So what is this ROC? This ROC is nothing but the region of convergence. Region of convergence. So what is this region of convergence? ROC. This ROC is defined as the range of values of S for which the Laplace transform converges. For which the Laplace transform converges. And how will you find out the ROC? We can find out the ROC from the given solution. For example, let's say the solution of the given signal is you get something as e power of a minus a s t. For example, let's say this. So to get the solution for the ROC, you say that the condition is that e power of minus st should be equal to 0. So when is it possible? It is possible when s takes the positive integer values. So this means the s, it is possible only when, s takes, s can take values greater than or greater than 0. So for all such values which are of s which are greater than 0, the real values, the real part of s is greater than 0. So then say for this particular case, if this was the solution, condition is if this was the solution, not for all the cases, it's not a general formula. Assuming that you have a solution as e power of minus st, and then to say what is the ROC of this, we can simply say that to find out the ROC, the equation e power of minus st should be equal to 0. And when is it that possible? So you need to argue when is that possible. So this condition is possible only when the s takes on the positive integer values greater than 0. So well, fine. With this discussion, we conclude that if you are asked to find out the Laplace transform, you also need to find the ROC, that is the region of convergence, the range of values of the real part of S for which the Laplace will converge. Only then your solution will be complete. Okay, then we'll take up some numericals in the next lecture. Thank you for watching.